You are currently the only person in this conference.
Karthik sir? Sir, no sir, we are not able to hear you, sir. Yes.
Hello. Hello.
Sir, yes sir, you're audible, sir. Repriya ma'am?
Yes, ma'am. Ma'am, shall we start?
Yes, yes.
Karthik, sir, shall we begin? Karthik, sir?
Sir, is it audible, sir? Karthik sir?
Hey guys, hear me? Good morning.
Good morning, sir. Yes, sir. We can hear you, sir. Shall we start, sir?
Yeah, can you guys hear me?
Yes, so we will hear you, sir.
Okay, excellent, excellent.
Yes, sir.
So,
So can we start, sir?
yeah, we can start. We can start.
Yes. Hello and a very good morning, everyone. I welcome you all to today's webinar. Design Tree Service Consultants Private Limited has collaborated with us and put together an amazing series of seminars on various topics related to building services and structures. Design Tree Service Consultants is a multidisciplinary engineering consultancy company founded in March 2008 by dynamic and innovative professionals to bridge the gap between the ever-changing construction industry. They are one of the largest service providers in Southeast Asia, with branches in Bangalore, Hyderabad, Vijayawada, Chennai, and Kolkata, with a cumulative staff strength of 300 plus. Design Tree provides the professional and technical skills to plan, design, and supervise construction industry from wide range of services from conception to delivery, such as civil and structural engineering, public health engineering, fire and life safety systems, electrical engineering, HVAC and IBMS engineering. To begin with, it gives me immense pleasure to introduce our very first prolific guest for today's webinar. We are honored this afternoon by the presence of Mr. Karthik Bhat, uh, who is a technical director, HVAC and IBMS at Design Tree Services Consultancy. After graduating from mechanical engineering from Malad College, Mysore University in 2001, he began working at Design Tree Service Consultancy. His expertise in the design of sustainable air conditioning for buildings, hotels, shopping malls, hospitals, high-rise buildings, etc. He is also a lead accredited professional with 18 years of experience in sustainable HVAC and IBMS systems, diversified work experience in different organizations like DVP Consulting as a site engineer, potential consultant as a design engineer, and task as a general manager. His vast knowledge and design experience in different natures of job, from high-rise building to high-end residential buildings, from complex data centers to lab applications, hotels, IT buildings, shopping malls, hospitals, etc. Mr. Karthik Bhat also leads a team of 30 plus engineers. On behalf of McGANS Ooty School of Architecture, I welcome you, sir. Over to you, sir.
Thank you. I welcome all the dignitaries and all the students of McGANS Ooty School of Architecture. So it's my privilege and pleasure to share all the knowledge bank that I have with respect to building industry, and I expertise in air conditioning. So I'll start with my first, a very brief biodata of mine. Now this is something which related to a very brief biodata on the achievements that I have made in the recent past. And then I'll quickly run through the technical presentation on HVAC, which will be for half an hour. And then 15 minutes, we'll have question and answer sessions. So we can get into any question and answers with respect to the students or any queries that you have. So hope everybody can see the slides.
Yes, sir. Yes, sir. It's visible, sir.
Okay. So basically, I have done my mechanical engineering from Mysore University, and I'm a technical director of HVAC and HVAC and IBMS, and I expertise in sustainable designs in air conditioning, and have a diversified experience with respect to designing of IT buildings, hotels, shopping malls, hospitals, high-rise buildings, etc. Now, as we all know that India is growing with respect to its economy. So we should be very proud that we are one of the fastest growing major economy. And though we are a developing country, we have immense amount of opportunity with respect to growth and infrastructure. So now, as we all know, this growth comes in complement with the carbon footprint also. So the carbon footprint is something that we need to bear in our mind when we are designing buildings with respect to energy, with respect to building infrastructure. So all this, we are actually one of the third largest emitter of greenhouse gases that we should know. So there is a lot of responsibility on us to understand that any design that we implement as tomorrow's budding architecture students or any engineers, that we should give our best towards the design. And this mother earth that is there, we should allow further many more generations to come and enjoy this kind of privilege that we have today on this earth to enjoy, or rather to experience it, right? So I'm a lead accredited professional. So with respect to this accreditation, I'm knowledgeable enough, or I have been trained enough to design buildings with a lot of responsibility in terms of energy, in terms of recycled material, in terms of sustainability. So there are many aspects to it. So this accreditation course can be opted by every architect student and every engineer. So you can get in touch with me, and I can also guide you across, or I can next, when we go on with the lead presentations, I think one of my colleague Nupur will also help you across to make you understand how to get accredited to this course. It's a simple exam with a curriculum of study material. And then once you qualify the course, you will be an accredited professional to practice architecture, to practice engineering aspects of building design. So this is something which I would recommend all of you students, so that tomorrow you practice before you preach, right? Now, one more aspect of my achievement is like the house which I'm residing. It's a 6-year-old residential building. It's an independent house. It's a 1,200 square feet plot, and this is a green building. This is a LEED Platinum certified green building. So again, one step towards sustainability. I have ensured the topsoil is preserved. I reused it back. I have done rainwater harvesting. I have used efficient water fixtures. I have gone with rooftop solar panels of 2 kVA so that I bring down my energy bills. I'm using this renewable energy source. I have solar film on my windows. I have proper ventilation, natural lighting. I have used a lot of low VOC paints and a lot of recycled materials with respect to the building construction materials, like fly ash cements, fly ash bricks, and a lot of waste management has been taken care, and a lot of LED light fixtures and low electric power consuming equipments have been used. So this is about my residence that I live in. And a small edge towards sustainability is like I have developed the barren land recently within 1 year. This has been converted into a proper fertile agricultural land. This was 25 years not it was not cultivated. And this is my friend's property, which his ancestral property, which I bought it. And then I developed this into a very ecologically balanced place. So we have sustainable solar power, recycled water harvesting, recycled materials being used. Like the container is a 20-year-old container where I live in during weekends when I go there to do farming. And it's almost, my aim is to get into a zero carbon footprint, including my journey to the place should be in an electric car. I should charge my electric car and come back. So that's the overall intent, right? So today, whatever we do, we should not be consuming like I drive 100 kilometers, I consume about 100 liters of fuel, and that's an additional burden on the fossil fuels. So every aspect today, we as human beings have sheer responsibility to practice, preach, and then we should see that our mother nature remains intact. And as a personal hobby, I do wildlife photography, so I am expertised. This is just a hobby, and I do wildlife photography and landscape photography too. So this is my profile. Now let me get into the presentation part. Vaniji, can you get into the main presentation?
Yes, sir. Yes, sir. 1 second, sir.
Yeah. So next we get into the technical presentation. Yeah, thank you.
Yes, sir.
Yeah, so today, see, basically all you architects today are learning about building infrastructure, like be it residential, commercial, So you have been taught about architecture. Now, we are a co-friend to architecture, wherein we play a major role in terms of services. Now, for an architect, he draws out the outline of the building, the look and feel, the materials that go into the building. So we as engineers, we come into picture in designing the services, right from structures, mechanical, electrical, plumbing, fire. All these services are designed by us. And in fact, today the subject would be HVAC system. So with respect to HVAC system, HVAC system would mean heating, ventilation, and air conditioning. Since India is a tropical climate, heating would not be much applicable other than being in Kashmir or up north, where some seasons you would require heating, or Delhi, for example. But otherwise, primarily we would apply ventilation and air conditioning systems for the design of buildings. So basically, today I'll run you through a small introduction on air conditioning, a brief on the air conditioning system, the factors that contribute to the sizing of the air conditioning system, a basic refrigeration cycle I will explain you. I know I'll not get into too technical with you guys, but I'll just show you different types of air conditioning systems that day in, day out as architects you would come across in buildings, and then you'll understand. And also I'll touch base upon certain building important aspects like car parks, utility rooms, pressurization of staircases, lift lobbies, and then a small insight on the working philosophy of the of the air conditioning system. So basically, like architecture also, you have a lot of codes. So here in building industry also, we have a lot of codes with respect to the guidelines or references. So National Building Code is one of the key codes that we refer to for any building design. And this National Building Code scripts a lot of guidelines towards services, structures, firefighting, air conditioning, electrical, all the services. And including architecture. So there are a lot of guidelines. So this is the only code majorly that we follow in India with respect to building services. And also adding to this, the Energy Conservation Building Code, the ISHRE chapter handbook that we follow, and ASHRE chapter handbook that we follow. So this is subjective to our air conditioning references. Now coming to the fundamentals of HVAC, that is your air conditioning system. So basically, as I told you, HVAC heating stands for H stands for heating, V stands for ventilation, and AC stands for air conditioning. Now, all this is a technical philosophy wherein when we say heating, it is heating up a place, maintaining the air quality inside a place, and then the humidity levels and everything. And this is primarily used in your cold climatic conditions. Ventilation is something wherein we bring air changes to the place. That means we bring in air and bring out air. So that means the number of times we bring in the air changes is as per the guidelines. So if you see a toilet, we ventilate the toilet. If you see a kitchen, we ventilate the kitchen. Now, with respect to ventilation, there are many aspects in order to remove moisture, odor, smoke, heat, dust. Now, with respect to air conditioning is something giving you comfort temperature with respect to compared to the ambient temperature. The inside conditions are more controlled with respect to dust, with respect to humidity, and with respect to temperature. So this is what the key definitions with respect to heating, ventilation, and air conditioning. Now, there are some primary goals in the HVAC system. Now, this primary goals would be it would be varying with respect to the application. Now, with respect to IT buildings, it's control of temperature, humidity, dust, and everything inside an environment. Now, once it comes to pharma or healthcare or hospitals, now the importance of hospitals with this COVID catching up and the pandemic. You would have seen the importance of hospitals where the isolation wards for the patients, all this is air conditioned and there is an isolation given. So air conditioning plays a very major role so that the disease doesn't spread inside a hospital. When it comes to hotels, shopping malls, entertainment, it's all comfort. So we need to create good comfort so that people get inside those places and they feel comfortable and the indoor air quality is maintained. Now, so all this comfort would lead to satisfaction, comfort levels, improve your livable conditions. And basically, as we all know that we breathe in carbon dioxide and we breathe in oxygen and leave out carbon dioxide. So it's very essential that we have adequate amount of oxygen, because buildings are getting contained. Day in, day out, we are seeing more of a contained atmosphere, wherein buildings are more glazed, more contained, and there's no natural ventilation. So air conditioning plays a major role in order to get in fresh air mixed with the air conditioned air, filter it, and then distribute it across to you. So the major objective would be to control your temperature, humidity, air purity, and with respect to maintaining a kind of positive pressure so that outside infiltration doesn't enter into your building premises. Now, a few terminologies like cooling, heating, dehumidification, all this. It's very evident that you would understand. And with respect to noise levels, filtration, getting amount of fresh air, indoor air quality, all this is prime intent of the design of air conditioning. Now, if you see the importance, as I told you, we need to create a healthy environment inside a building. So be it high-rise buildings, cinemas, libraries, as we breathe in oxygen and leave out carbon dioxide, it's very essential to keep the air quality very intact inside a building. Otherwise, we enter into a sick building syndrome, and then we breathe in more of carbon dioxide, then we get sick, and we breathe in more of volatile organic compounds. So building inside consists of a lot of carpets, a lot of construction elements like paints, like your computers. All this would emit certain radiations and volatile organic compounds. So it's very essential that all this is regulated and controlled. Then only we can enjoy a very controlled atmosphere inside a building. Now, even this is applicable to your industries, where your textile industry, your electronic industry, pharmaceuticals, process industries, precision manufacturing, ventilation of warehouses. So it's a very diversified field, this air conditioning, wherein for you name a building and then we have a responsibility there. Now, what are the factors that affect air conditioning? So basically, as an architect, you would design a beautiful building. Now, this building would allow certain amount of heat to transmit inside. There is lighting. So this lighting would emit heat. There are computers that will emit heat. There is occupancy. Every human being has got heat inside him. So, there's latent and sensible heat. And the amount of fresh air that we get in from outside also consists the atmospheric temperature, heat, dust, and everything. Now, with all these factors that we get in, we calculate the heat load, and that is what derives the parameter called as air conditioning load. So these are the load components. If you see, this is just a pictorial view. When we have a cooling unit, we get the air conditioning air and we take it back to the unit. And there is transmission of solar transmission. There is roof transmission, heat load, flow transmission. So these are the various factors. There's just a pictorial view of that. So to explain you about the basic refrigeration cycle, it's a very simple concept. We use a media. We use a media which has got a boiling point lesser than the atmospheric temperature. So this is called as a refrigerant. So this, when it comes in contact with the air, it picks up the heat, and then we have a condenser. It goes to the condenser and the heat is rejected. So it's a simple philosophy where there is a cooling coil which is subjected to the space, and this picks up the heat from the space and it is thrown out. A very basic philosophy. So this refrigerant has a certain property. So we have compressor, condenser, expansion valve, and evaporator. So this is too technical, but yes, to understand simply, an air conditioning device would pick up heat and then just throw it out into the atmosphere. So again, we have a social responsibility. As I told you, more number of air conditioners would bring up global warming, because this refrigerant is again a very key thing. Any leakage of this refrigerant would lead to ozone layer depletion. So again, today we are going into many green refrigerants which are being used, which I'll touch base upon. Yeah. So now coming to the type of air conditioning systems, we have split air conditioners. So this you see in your residences where you see your split air conditioners, an indoor unit which is inside your space, an outdoor unit which rejects heat which is outside the space. Then we have the decentralized VRF system. So many multiple splits are connected to one outdoor, a simple definition of it. And then we come into centralized plants wherein there is a large load like a building of 1 lakh square feet, 10 lakh square feet, 20 lakh square feet, a larger building where there is a central cooling plant that circulates chilled water to the air conditioning machines. And this chilled water picks up the heat and goes back to the rejection point. So very simple definitions to you guys to understand what is air conditioning. Now, the first system, the split air conditioning. So this system is used by most of the residential buildings, small applications like 200 square feet, 300 square feet, 100 square feet applications, where we hang this high wall unit onto the wall. And we can have high wall units, we can have fan call units, we can have different nature of units. And it's piped through a refrigerant pipe and a drain pipe for condensation. And it's connected to an outdoor unit. So this is a basic definition of a an indoor-outdoor unit concept. So this is a typical drawing wherein you can see the outdoor units and then the indoor units like cassettes, high wall units. Now coming to the VRF units, it's almost similar to split, but we have multiple units connected to one outdoor. That means there'll be multiple offices. So you'll have air conditioning units. This will be connected to multiple outdoors. So this is for your commercial application. So typical indoor arrangements, like this is your architectural drawings, wherein you see your your indoor unit and it's ducted. And then we have air conditioning throws into the spaces like conference room, cabins, and all that. So this is your VRF system. So one outdoor can connect to multiple indoors. One outdoor can connect to multiple indoors. So when you take a high-rise residential building or you design largest luxury spaces, so people would not like to see multiple outdoor units. So that means for every one air conditioning unit, you cannot see multiple outdoor units, right? So absolutely. So what happens is we would love to see more indoor units, but not many outdoor units. So we can connect up to 48 indoor units to one single outdoor. So this outdoor unit can be placed on the terrace level and the piping distance can be up to 115 meters. So this is a revolutionary technology called as VRF technology, originated from Japan. So wherein the refrigeration pipeline distance is not limited. But whereas in split AC, you have about 15 meter of pipeline limitation. So this is how the outdoor unit looks like. And this is connected to multiple indoor units. So this is how the indoor units look like. So these are hideaway units. You can't see the units. They hide away inside the false ceiling. So this can be arranged in terms of cassette units, in terms of different types of high wall units. So now coming to the larger plant, that's your chilled water system. So that's again for the larger buildings, like larger commercial buildings. Now, if you're designing an office space more than 1 lakh square feet, 2 lakh square feet, you cannot have those split ACs or VRF units and number of outdoors, number of maintenance points. So what we do is we go for a centralized air conditioning plant wherein we have water cooled system, we have air cooled system, and we have a hybrid of air cooled and water cooled system. Now, what are these water cooled, air cooled, and all this terminology would sound very new to you. So basically, these are nothing but chilled water generating machines. So it's on a simple concept. How I would explain you is these are chilled water generating machines. So these machines would be kept on your rooftop or your basement, and this would pick up the heat through your air handling units, which are connected to the indoor spaces, and reject the heat out to the atmosphere. So a very simple concept. Overall perspective of air conditioning is we are cooling a space, we are maintaining the humidity, maintaining the filtration levels, and we are rejecting the heat outside to a building atmosphere. So that's a simple philosophy. So you can see we have a chiller plant located for multiple buildings together also. So this is a central cooling plant, and you can see the piping network connected to individual buildings. So we have pumping system. So the chilled water is pumped into the buildings, and inside the buildings we have air handling units. So these air handling units are nothing but fan, filter, and coil. So the water circulates inside the coil, the fan will blow across the coil and ensure that there is cold air into the spaces. So this is a very simple block diagram showing, a chiller plant, pumps circulating to the indoor machines. So next, when I get into the next sessions, I'll get into the drawings. I'll get into Rivet, three-dimensional drawings, which will be more self-explanatory to all of you. This is just a very, very brief introduction to air conditioning. So on the water side, you can see, so the chilled water is distributed to the air handling units. The pump sets are the circulating devices which would circulate water into the air conditioning systems. So now architecturally, what we do is on the buildings, we generate plans, sections, we create the footprints of these equipments, and we do a spatial coordination of all these spaces. So this is how a typical building floor plan looks like. So since you all are architects and you are very familiar with the building plans, so this is one sample building plan which I'm displaying. So where this has got a center core of lift, and then the services are behind. If you can see the services, these are the services which are behind. There is a toilet core, there is an air handling unit room. So to this air handling unit room, there is a feed of chilled water which comes from the central plant, and there'll be a duct distribution overall around the space. Through ducting, we would be distributing the air to the different zones of your space. Like there might be workstations, there'll be cabins that you'll plan inside a space. So this is a typical arrangement for an IT building. So if you see this IT building plan, this is surrounded by glass, so it's all glazed for natural light, and light is again complementary with heat. So we use double glazing to minimize the heat ingress into the building, and then these are the air handling units which would take care of the cooling mechanism inside the space. So very simple floor plan to explain you. So architecturally, what we do is we initially plan with the architects the footprint of the air handling unit room, the toilet ventilation, the pressurization of the lift lobbies, then the pressurization of the staircases, the egress routes, so that in case there is a fire inside the building and when you're escaping, these are the staircases that you escape through. And when you escape through the staircase has to be pressurized with positive pressure. So I'll explain you about pressurization in the coming slides. So this is a typical floor plan in an architectural, IT park, how a typical floor plan looks like. So this is an enlarged view of an AHU room. So this is how the air handling unit in a two-dimensional drawing represents. So if you see, it's nothing but a room with a cutout. So you'll have the chill water risers emerging out from the basements, and then the ventilation drawn from the external facade. And then this air handling unit is a mechanical equipment which supplies supply air and collects back the return air. So in air conditioning of this type of air conditioning, almost 85% of the air is recirculated. Only 15% is the makeup air that comes into the space, and that's what we need for breathing and maintaining the air quality. The rest of the air goes back to the air conditioning system, filters, and then again comes back. Otherwise, the energy bills would be very high. You can understand the atmospheric temperature. If it's about 38, 39 degrees, we bring it down to about 22 degrees at the space. That means the coil temperature is about 18 degrees, 19 degrees. So from 18, 19, when it comes to your space, it becomes 23, 22 degrees Celsius. So the space ideally is maintained about 23, 24, ideal temperature of a human comfort, which everybody is comfortable with. Now, essentially, in a building, car parking is very essential. As you all know, as architects, you need to provide car parks. Now, today, buildings have gone high-rise, buildings have gone below basements. That means we go below ground level also to construct basements. Now, as you all know that cars, they generate emissions. Now, whenever we have the vehicles ignited or the vehicles in a running condition, So they leave out very toxic fuel called as carbon monoxide. Now there are certain building regulations that we need to follow and ventilate the basements. Otherwise, this toxic smoke inside the basement would kill us, and rather would affect the human breathability. So what we do is we have a building code which says that either we ventilate the basement naturally. That means, suppose if the basement is partially underground and partially above, then there is a chance of providing 2.5% opening in form of window openings or in form of slab openings to the podium, where we create light and ventilation wells. And by means of this, we allow the ventilation to happen naturally. Now, in case we cannot create the ventilation to happen naturally, we need to force it. That means we need to have mechanical ventilation fans to force out the air with respect to ventilation system. So this is something that a mechanical engineer like me would design in context with the architects. So what we do is, for every 3,000 square meter of basement area, we design the basement ventilation system. So mechanically, what we do is, for every 3,000 square meter, we create a fire sprinkler curtain, and then we mechanically ventilate it with close to 12 air changes. So 12 air changes is something like 12 times the air is changed per hour inside a given space. So 12 times I would be changing the volume of air inside a space in 1 hour. So that's what is called as 12 air change per hour. So this is the rate of ventilation that we need to provide inside a basement for fire mode. That means, see, generally in car parks, there might be a car that might catch fire. There'll be cylinder based cars, there'll be fuel based cars. So all these cars can catch fire, and accidentally when they catch fire, fire is not the killer. The smoke, the toxic smoke, is the killer. So what we need to do is we need to ventilate the basements with air changes, so that we have sensors, and these sensors will activate the fans and keep the basement ventilated for normal mode as well as for your fire mode. So architecturally, what is your role? Your role is to first try to create natural ventilation, so that mechanically we don't ingress any cost or operational aspect. In case we go 2-3 levels lower, then we have to mechanically ventilate. So that means the upper level, if we can create 2.5% opening, we can avoid. The lower 2 levels, suppose it's a 3-level basement, the lower 2 levels, we have to mechanically ventilate them. So we ventilate using jet vent fans. So that means we push air from one side and pull it out from the other side. So there should be a proper air circulation in the basement. So we create, axial fans. You can see them mounted on the wall, and this is connected to a riser. And these are intermediate fans. Those are jet vent fans. So these jet vent fans will push air from one end to the other. So simple, we have on one side axial fans, and on the other side, we have one more axial fan. One would push in fresh air, the other would extract exhaust, and in between we'll have the jet vent fans, which will push in and push out air. So this is a typical layout of a basement. Now if you see this basement layout, you can see in the periphery we have cutouts. So these cutouts come from natural grade, and here the fans are fixed. So these fresh air fans would inject air into the basement, and then you can see the small jet vent fans. This will push the air into the next zone, and that will push it out to the exhaust fan. So it's a simple philosophy or a concept where we get in air from ambient, we get it into the basement, and then we extract the air and throw it out into the ambient on the other side. So very simple concept of ventilating the basements. So now we have to have effective design. That means we need to have a proper airflow inside the basement and position these fans properly. And the exhaust and fresh air fans would play a major role. So we do a computational fluid dynamic analysis, which will enable us to, present it properly to you in terms of the effectiveness of the entire design of the ventilation system. Now, these are the natural openings. So these are the natural openings with respect to the provisions. So you can see them naturally how on the grade level the cutouts and openings are provided into the basement. So basically, we can't run a mechanical system throughout. So it's all demand control ventilation based. And this demand control ventilation based system is something which when we operate, this system ensures that we bring in fresh air and take out exhaust. And there are a lot of sensors with respect to carbon monoxide sensors. So these sensors would sense the requirement of the air circulation and increase the speed of the fan. So that's how you save power and energy. And the maximum allowed exposure would be like 25 to 35 ppm of carbon monoxide inside a space. Beyond that, it will be toxic. Now, as I briefed you about air conditioning and ventilation in the basements, there is something called as restrooms, toilets. These toilets and restrooms also need to be mechanically ventilated. So again, there is a air change philosophy. So we go with 10 to 12 air changes for the toilets to be ventilated. So we get in air intake and then we exhaust. So it's a simple concept: push in air and pull out air. So push and pull would enable air changes inside a space, and the stale air can be removed from a space. So it's a very common philosophy. For any space that you want to ventilate it, you should have an exhaust fan and a natural drawing lower you can have, so that the air comes in through the negative pressure, or you can have a fan which will again push in air and push out air. So you can use mechanically both the fans, or mechanically one fan, and the other side you can use natural lowers to draw in air. So again, utility rooms are also ventilated. So there are certain norms that your electrical rooms, your firefighting rooms, your plumbing rooms, all these are ventilated. Now coming to staircase pressurization, as I told you, in a commercial building or any high-rise residential or a residential building, the staircase plays a major role in terms of the egress. That means you need to evacuate outside, you need to escape out during fire or during emergency. Now this staircase, as and when we start presenting you the firefighting services, you'll understand the importance of the firefighting services into a building, like how air conditioning plays a role. You have electrical, you have firefighting, you have plumbing, you have all the systems that contribute to a building infrastructure. Now when it comes to air conditioning, we ensure that these places are safe in terms of egress routes. So what we do, we maintain the staircase at positive pressure so that the smoke from the office spaces doesn't ingress into the office spaces. And because of this, what happens is the entire space is properly ventilated and it is at positive pressure. And because of this positive pressure, the space is intact with respect to a safe egress. The smoke doesn't enter into this particular space. Now, similarly, like staircases, we have elevators in the buildings. So that means we have, your lifts and lift lobbies. Now, the lift shaft is a core wall. The lift elevator moves from ground level to the terrace, or it's got a movement. Now, whenever there is fire in the building space, the smoke enters into the lift lobby. So this lift lobbies have to be pressurized with positive pressure so that the smoke doesn't enter into the space. So it's a simple concept and a philosophy. Again, we have certain norms and pressurization guidelines. The lift lobby, the staircases, and the lift wells have to be pressurized. So again, there are norms which allow you to naturally ventilate these places also. So in case you want to naturally ventilate these places, given a point you don't want to mechanically ventilate, as architects, you need to create cross ventilation. That means any lift lobby that you have, you should have cross ventilation into the lift lobby. That means on two sides of the lift lobby, you should have ventilation to the external atmosphere so that you can avoid mechanical ventilation. So this is the norms or the rules or the philosophy that has been arrived by NBC 2016 guideline, and this is what we follow. In case we don't, the facade or the elevation plays a prime important role, then we mechanically ventilate or mechanically pressurize these spaces. So as I told you, staircase pressurization, either we naturally ventilate it or we pressurize it with a mechanical fan. So this is a typical representation of that. So just the last slide of the presentation. So this is something related to atriums. Now you all would have visited a lot of shopping malls, large shopping spaces. So you would see a lot of entrance lobbies and huge triple height, 4 height lobby spaces. Now these lobby spaces are also like a smoke chimney. So in case of fire, the smoke would fill up into the spaces, and then we need to evacuate the smoke as soon as possible. So now the challenge in buildings is to create controlled atmosphere, controlled environment, and also to ensure that during fire, we give you a safe egress to escape out of the building. So this is a very brief presentation that I had prepared for you students. So thank you on the presentation, and I would move on to the questions and answers. Over to you guys.
Thank you, sir. Thank you for an insightful and an informative presentation on the HVAC systems. Now, to the audience. Guys, it is open for question and answers. You can either type in your questions in the public chat, or else you can voice over it over the mic too.
Excuse me, sir.
Yeah, Fatima ji, please tell me.
Sir, can you just brief about the working of HVAC system in a multi-level parking?
In a multi-level parking, there is ventilation only. So basically, in a multi-level parking, if the multi-level parking is enclosed without any natural ventilation, only then you'll be ventilating it. Otherwise, it's all natural ventilation. So as per the regulation, a multi-level car park doesn't need any ventilation system. So it's all naturally ventilated. You don't need any mechanical ventilation.
Okay, sir. Thank you.
Yeah, please tell me.
Sir, with respect to the use of refrigerants in HVAC system, what is the sustainability of this? What kind of refrigerants is there an option for using green refrigerants and all that?
Yeah, since there's a very age-old technology, like centuries together, air conditioning has been there in the industry. So there are many refrigerants in the industry. Like today, what prominently we are using is R134A. And tomorrow, there are a lot of futuristic refrigerants that are coming in. And these would come into picture, because primarily what refrigerant does, as I told you, is to pick up heat and just to throw it out. Now, this is all enclosed inside, pipe in, pipe out. Now, the issue comes with the refrigerant is when it leaks. So this refrigerant, when it leaks, it harms the ozone layer, and it also leads to global warming potential. So refrigerant definitely plays a major role. So R134A and the futuristic refrigerant which would shortly come in. So these refrigerants would replace the industry.
Yes, so thank you for that. And I am a landscape architect. I am associate professor at McGANS. So I was a little curious to know about the topsoil protection when you were talking about your design of your own house, the residential building. So I was a little curious to know how it was done.
Yeah, so basically, see, what we need to understand is the topsoil consists of a lot of macro and micronutrients, right? Now, what happens when you're constructing a space? You need to excavate the space. Now, you need to excavate like 1 feet of soil on the top is called as a topsoil, like 1 feet or half a feet of soil. Now, this soil you need to excavate and keep it separately so that you can replenish it back once you're doing a landscape, because this is rich in nutrients. When you see this is exposed to your sunlight, and all the macro and micronutrients are intact in this. Now you see farmers, when they till the soil, they till only the top layer. They don't get deep inside 10 feet and then they start farming, right? So that's the whole concept. So whenever you're building a space, ensure that the 1 feet of soil which is rich, if you find that it is rich without any debris or any construction debris. It's pure soil. You remove it, keep it, preserve it, cover it with a tarpaulin or something, and then reuse it back once you construct for your landscaping. It'll be rich in nutrients.
So preferably the soil could go for testing also to determine the alkaline values and all that, the acidic values and all.
Absolutely. If you find the topsoil really rich enough, good in terms of nutrients, you can replenish it. That's what sustainability calls for. See, today, otherwise you would excavate, you would throw away the soil, right? Now this soil again you will excavate from somewhere else the top layer and get and start using for landscaping. That means it's an imbalance that you're creating. You're throwing away your topsoil, you're getting topsoil from somewhere else. So this is the balance that we need to create.
Yes, sir. Thank you so much.
Yeah, I think Neenu has asked a question that how to calculate the AHU room size. Now, that's a very good question. So for every 12,000 square feet, a 5 by 5 feet by 5 feet AHU room would be good enough. Again, the technology adoption of type of AHU would define the sizes, but you can take it as 5 by 5. Archana has asked a question: what is the peak cooling latent load and peak sensible load? What are the values, range, space? So this is again subjective. As I told you, for an air conditioning space, latent and sensible load would contribute to the overall load. Now, as a human being, I have latent load and I have sensible load. So every heat aspect would have a latent and sensible load. So all this put together, we have to put it into the calculation software and then derive on the heat load calculation. Yes, I think Navneet asked a question that whether the AHU room needs ducts. Definitely, they need duct. So basically, the AHU is an equipment. Now, this equipment needs to be piped with chill water pipes. So we'll have a small cutout on the back side of the AHU room, which will transfer the electrical cables, the chill water pipes, and the fresh air if you are getting it from the rooftop. So definitely, it will have a duct. And from the AHU, there will be ducts coming out with respect to your GI ducts. This GI ducts will run into your spaces to distribute the chilled air. So what I'll do is I'll share lot of documentation in terms of the reference guides. So these guides will be helpful for you. So whatever I'm speaking about, the NBC guideline, whatever soft copies I have, I'll share with your college, and then this can be shared with all the team members. So these reference guides can be easily referred to, and you'll have my mail ID. You can communicate with me. You'll have my telephone number. You can call me for anything, any aspect on sustainability or any personal hobby, like I've shown photography or the agricultural aspect. So anything, you can feel free to get in touch with me. Any further questions?
I think there's a
that jet fans need any specific rooms or how it connects to the outdoor, sir. So we have a question from Rahul, sir.
So can you just repeat?
Jet fans need any specific rooms?
Okay. Okay, that's a good question. So basically, there are two fans. One is axial fan, which is on the periphery of the wall, and jet vent fans are hung in the ceiling. So if you go back to my presentation slide, there are actually two different type of fans. So one fan would be the axial fan, and the other fan would be jet vent fans. So this, if you can see, this is the axial fan. So this doesn't need any room. This can be mounted on the wall, and this can be mounted on the ceiling, the jet vent fans. So the exhaust fans are all fire rated for 300 degrees Celsius, and they can be openly hung in the ceiling. So only thing is, if you want to curtail the noise, you can create a fan room. So in case you want to bring down the noise level, because these are very noisy fans, they create up to 76, 78 decibel of noise. So in case you want to bring it down, then you can create an enclosed room. So create a room and acoustics inside the room, and then try to bring down the noise levels. Or else you can have variable frequency drives and run these fans at 50% capacity, so that the decibel level also comes down. So that means only during fire, the noise of the fan is high, and which is acceptable, because during fire, we are more important to egress out of the building. So the noise level doesn't matter to us, right? So hope that answers your question. The jet vent fans are these, and axial fans are these. So it's not mandate to have enclosed rooms for axial fans. But yes, in case you have multiple basements, now you have basement 1, basement 2, basement 3. Each and every basement will require dedicated exhaust riser and dedicated fresh air riser. You cannot combine them. So then you'll end up with multiple number of fan rooms. Now, multiple number of fans and fan rooms. So and shafts. So what you can do is you can combine using single riser and have one single fan room. You can have 5 dampers, so that multiple basements are connected to one riser, but there are 5 dampers. So that means we presume that not all the 3 basements catch fire at a time. So the other 2 fire dampers would close. That means basement 2 and basement 3 will close in case basement 1 has caught fire. Basement 1 fire damper will open and push the air out. So that's a very common philosophy that we are using to optimize on the number of risers that jet out inside a building. Otherwise, you will see number of pop-ups landing up into the architectural podiums. So these podiums we can optimize. So that's how we as HVAC designers would work closely with you, so that the aesthetics is met, then the functionality is met, and we don't compromise on any of the life safety aspect. Yeah.
So we have another question from Ashwati. We give a separate fan room. Will it affect the efficiency of the fan in any way?
No, it doesn't affect, because it will be enclosed in a room with fire dampers. So that means, you'll have the fire dampers which will open up, and this will allow the air to get. So it's a matter of little static pressure, incremental static pressure, which will be required. That's all. But otherwise, it's not a And safety wise, you can enclose the fan room so that it's a mechanical equipment, so that accidentally nobody goes and accidentally touches it, or a car goes and hits it, right? So you can enclose this within a car park space, so that the life-saving equipment or device is safe. So Arun's question, is it possible to use jet vent fans for habitable spaces, which is underground? And how does the frequency? So this jet vent fans are primarily used for only car parking. So because these are large in dia, like 350 diameter, almost 1.1 feet above. And, this can ventilate. Like this has got a dynamics where it will push air from one place to the other. But primarily, we would insist for a car park space or a tunnel ventilation, wherein you have tunnels connecting underground tunnels. So this is where these jet vent fans are used. Otherwise, they are not used for a habitable space, like office spaces. All these, we have better technology, like we use enclosed ducts, which are hidden inside the false ceiling. So we do the air changes through these ducts, and we have fans inside fan rooms. So that's a different concept for habitable spaces. So there is a guideline book which would refer you to different air changes. So as NBC is a guideline, this will have for basements, what is the air change, for for toilets, what is the air change. So all this effectively it's defined. So we need to ensure the calculation goes into place and we size the systems accordingly. So we select the equipments accordingly. So that's our role and responsibility. And placing those equipments in the facade. So for example, if I am placing a toilet exhaust fan, I need to embed it in the architectural element. That's your facade. So the toilet exhaust is thrown outside the building. In case you don't want to see the toilet exhaust being thrown out of the building in form of a louvre, we take it as in form of a riser. So we duct it out and throw it out in the terrace so that we don't see these mechanical equipments or elements in the facade, and the facade is clean. Otherwise, the moment we create louvers and other things, so they would create a maintenance aspect wherein you need to clean the louvers once in a while. So it all depends functionally what you want to do, whether you want to take it up to the terrace level and don't want to create an elevation which is non like elevation plays a prominent role, or space plays a prominent role. So in case I use space as a prominent role and I have to duct and use some space inside the toilet, so that means I need to enclose that space, put a riser, extract it and take it up to the terrace. So it's all between the internal space and the external facade. So we need to balance between both of them.
Yes. So we have another question. Yes, we have another question from Deeksha.
Yeah. So there are a lot of passive cooling ventilation strategies. See, one thing we need to understand is India is a very dusty atmosphere, like we are a developing country. So what happens is all this is very good on papers that we say we create natural ventilation for occupied office spaces. Now I'm concentrating on larger office spaces or IT spaces. Now these IT spaces have very clean atmosphere inside. They have computers, they have clean atmosphere. Now we cannot use a lot of passive aspects like create natural ventilation, cross ventilation for these spaces, because they come in complement with the dust. And when it comes in complement with the dust, it comes complement with the pollution levels outside. So we can use these technologies where probably places which are blessed with atmosphere, and probably they are located in very isolated places and they have a real very, very nice campus. Suppose if you go to Infosys has such a nice beautiful campus, acres together. So in Infosys campus, you can think about passive ventilation, you can think of a lot of other cooling aspects, but not for the regular building. What we do in regular buildings is we use free cooling. So the air handling unit itself acts as a free cooling equipment. So during night times, we draw the ambient air and then we push it inside the space and we purge it out, so that during ambient temperature is less. That time we use this natural ventilation and occupancy is less. Otherwise, it adds a lot of load onto the filters and adds a lot of load onto the other aspects, because the moment you are creating those air changes, you purge in and purge out a lot of air. But in air conditioning, it is only 15% of external air and 85% of recirculated air. So we maintain that quality of air intact.
Yes. So we're expecting a lot more questions because our third year students are dealing with high-rise buildings in this particular semester.
Yeah, we will have one presentation on high-rise buildings, which will come in shortly in the future. So the next presentation will be on electrical. Then I have given a schedule, so that schedule can be shared with your team. And high-rise specifically, we will discuss on high-rise buildings, because high-rise buildings have a very different nature and complexity altogether.
Yes, sir. Yes,
Good morning,
thank you.
sir. One second. Good morning, sir. This is Lakshmi Priya. I'm assistant faculty in McGANS Ooty School of Architecture. I have one small doubt. When it comes to office enclosed spaces or malls, we will go for mostly centralized AC system because it's very sustainable. But is it there any ways that we can attach that PIR sensor, passive infrared sensors, to count the occupancy and make it more sustainable in automatic way?
Yeah, see, all the systems are basically automized. See, when I'm setting a thermostatic temperature of 24, say, in a space, the moment the temperature is achieved, we have backend integration on the chilled water to regulate, the fans will regulate, and the air conditioning system will regulate. So all this will lead to control of temperature, humidity, and also power. So that means, see, now I have 100% demand. The equipment will perform 100%. When the demand is less, it will perform lesser than that. So that means in a shopping mall, typically your question, like during 6 o'clock or 4 o'clock, there is a peak occupancy on a Sunday. Now the air conditioning system is throttled up to the full of its capacity. But 11 o'clock in the morning, there are hardly any people. There's just an early morning. So 10 o'clock or 11 o'clock, just the start of the shopping mall, the air conditioning systems are switched on, but what they adopt to the partial loads. So the partial loads are adopted, and the systems would throttle down to cater to only the given requirement. So this is your backend integration to all your chilled water valves, your variable frequency drives. So your chillers will have variable functionality, capacity, and everything.
So that will make hold the building into a particular comfortable temperature according to the occupancy, right?
Yes, we need to create that kind of temperature. See, when you're going for shopping inside a closed atmospheric building, you will suffocate otherwise. You will not feel comfortable, you will not shop. Now you go into a hotel, you go into the lobby of the hotel, it's so stuffy. You'll not feel. So the comfort level is something which we define that yes, 23, 24 is a comfort level for people. There should be good air circulation, and that's how people would live in that space for more time. Otherwise, people will not shop. They'll just come out if there's no comfort level. So being in a tropical country, we have to create this kind of an atmosphere.
Sir, actually, like when we create a comfort level throughout an enclosed space, the occupancy may be vary. For example, the atrium space, the occupancy may be high. In certain shops, the occupancy may be less. And we use completely centralized system. So everything gives a complete set of temperature. So is any modification that we can do it in centralized air conditioner systems with the sensors, so that we can create certain cooling only in the occupied spaces, heavily occupied spaces?
Yeah. So what we do is we don't design typically a same air conditioner for all the spaces. So we have zonal definition. So for example, we treat the lobby as one zone, the entrance lobby. We treat the retail space inside as one zone. So for every zone, we have a different air conditioning and sized as per the actual load. So we calculate the worst peak load, and then we say that the lobby would be populated with 200 people. So this is the worst load. So we will calculate that particular zone with that load, and that will have a dedicated air conditioning for that particular zone. So zone wise, we have to calculate, and then we'll have to size the air conditioning unit, and that particular air conditioning unit will be limited to that particular zone. So every retailer will have his own air conditioning unit. Every common area space will have its own air conditioning unit, and this is bound by all the levels.
Okay. Thank you, sir. Thank you so much.
So I think Ashwati has asked me a question: lighting and ventilation be induced in form of tubes in building, like solar tube lighting. See, lighting has become very sustainable these days, and definitely solar lights are very, very well adopted in form of tubes. So I didn't get your specific question actually. See, actually in air conditioning, if I can define, there are various other means of air conditioning where it is called as radiant cooling, where we embed pipes within the slab. So that means you don't see any air conditioning devices at all. And this is by means of radiation theory, wherein the radiant cooling, it will cool the space. So only the fresh air needs to be treated and got into the space, but otherwise all your pipes are invisible. So this technology we have implemented in a net zero building design with Jaguar corporate office in Manesar, where the power was generated through solar, 650 kilowatt of power. They had a large space on the ground, and we implemented radiant cooling. So we had chillers which were generating chilled water, and this chilled water pipes were embedded in the floor of every slab. So through the floor, the air conditioning would be emitted. Like there'll be process of convection, radiation theory, wherein the air conditioning would be cooling the space. So that's also a beautiful design, but not recommended for a tropical country, because what happens is any ambient air that comes in contact with the air conditioning pipes would again lead to condensation. So the building has to be well intact with respect to the no leakages, and then it should be really the no ambient air coming inside. So we'll have to design it very specifically so that we can implement the system.
So adding on to Lakshmi's question on automated systems for management, is there any facility management system that you incorporate during the design stage of the HVAC systems? Or
Yes, so we'll be presenting integrated building management system in the due course. So that that will have a brief insight. See, basically all those equipments like electrical, plumbing, firefighting, your air conditioning equipments. Today we are in an era of futuristic technology, where sitting in my laptop, I can control all the equipments. I can visualize all the equipments. I can see how the equipments are functioning, how much power they are consuming. So that technology we are adopting for all the buildings to make them smart. So we call them as smart buildings. So all our equipments are also smart. That means the air conditioning unit can talk to the internet. And this is the next futuristic thing, where on an internet I can just log into any device and see them, and then control, visualize. I can control the temperature, and see, I can create a lot of sensors in your space to have a realistic real-time data of your space temperature, space pollutants inside your space. All that can be done, and this is what we are doing for all the futuristic buildings. So we will present that also in one of the sessions.
Yes, sir. Sir, another question: is there any digital twin, or how much is BIM involved in this services? So, is still while you design, do you still collaborate with the architects at the design stage, or is it still after the design stage that the service people collaborate? So,
see, I'll tell you, the future is going to be BIM, right? See, what happens is today, I mean, I've also used the drafting board and all the mechanical equipments to draw. Now the future is something which is using more of CAD and Revit. So Revit is a 3D platform. So architecturally, if the drawings are drawn in Revit today, mechanically also we are drawing Revit on Revit. So if possible, we have a Revit team also. If we have some time and sessions available, we can touch base on Revit platform also. So that's a very interesting field, because everything you can see three-dimensional. That means you can create the building three-dimensional, you can generate the services three-dimensional, and it's so easy. There's clash detection, there is a bill of quantity arrived out of Revit platform. So Revit is really emerging, but it's an expensive software. So we don't offer to all the clients. It's like it's a paid version, because every license costs us. So we charge the clients, and architects also charge the clients, because there's a lot of work, manpower, and cost involved in Revit. But it's a wonderful
yes, sir. So actually, my master's is in building information modeling. I've done master's in building information modeling. So to an extent in India, I actually have not come across any huge projects where BIM has been applied at an extent rate. So it is still just in a very primitive and
no. No. I mean, today, almost you call it what all campuses we are doing or what all futuristic buildings we are doing. It's all with Revit. So there are a lot of foreign architects involved and a lot of local architects involved. And today, all the clients know the value of Revit, because it's so easy to make changes. Once the model is generated, you can easily change, like how you use SketchUp. In SketchUp, you can take multiple sections, you can take multiple views. So similarly, in Revit also, you can cut down multiple sections, multiple views. So two-dimensional drawing is initially what we do. We do the spatial allocation, we do the outlines, and then we convert that into Revit once the plans are approved. So Revit is catching up. I mean, it is the very need and necessity. So for every architect, I would say that if you are well trained in Revit, then it's the future. Like today, if you see salary levels also, people who are paid for a two-dimensional drawing versus people who are skilled in Revit, they get more well paid, So more the level of skill sets that you have in terms of sustainability, in terms of Revit qualification. So I would say when you have time, you add on these additional qualifications, add on these additional trade and skill sets. So this will really drive you to a very being a very bright architect or an engineer.
Yes, sir. Participants, is there any questions? So, Dilip Raj and Pranit, the sort of type. Let's wait for the questions.
Okay, that's a very good question. Radiant cooling. See, when the pipes are embedded in the floor, dehumidification is possible by means of DOS system. That means I need to have a separate treated fresh air unit. So the oxygen requirements or the air changes are met by the treated fresh air unit. So hope that answers your question. That means the cooling mechanism is through radiant, but the fresh air which has to be drawn from ambient is pre-cooled, filtered, and then it is given into the space. So that's how the air conditioning philosophy works for radiant cooling. So we have Praneeth asking us, refrigerant, what is the significance between PCC and CFC? So this is the this is the content. Basically, CFC means chlorofluorocarbons. So this is the chemical composition. So I'll share a few documentation on refrigerants, which will give you a clear insight on the futuristic refrigerant, the formulation. Because technically, again, if I get in, it'll take hours together. So I'll share a lot of details with you guys.
Yes, sir, that'd be very helpful. Yes. So, guys, is there any questions? Any other questions?
So Priya, I think that's it for this
Yes.
presentation.
Yes. Thank you, sir. Thank you once again. That was a very, very informative question and answer session as well. Now, I call upon Dr. Sanal Kumar, our head of a department, to deliver the vote of thanks.
Yeah. First of all, I would say that a very informative session. It was a lot of, lot of exercises which we would have undertaken, but it would not have come down to a very, a concise form of presenting it. Like we would have spoke about it as design credit. We would have given a lot of discussions on this, but coming up with a technicality and coming up with a sequence and understanding of the whole process and making it very, very legible for the students. That was very, very beautiful about the presentation. That's my personal comment. But I would really, really thank our chief guest, Mr. Karthik V. Bhatt, for his informative session and for being a part of this initiative, which is going to be a series of webinars, a series of informative sessions for our students. It's going to be a big, association that we're expecting between McGANS and Design Tree. And this is kind of started off on a very good note. Talking about sustainability, we just came off from World Environment Day yesterday, and today we looked at an example of a professional. I appreciate that a professional in the field is living that with his own residence. So, sir, much appreciated that you're doing this initiative, and a big thanks to you and your team for being a part of this venture. And I would also, thank our dean, our principal, and all the faculties who have been part of this informative session. And also a special thanks to Professor Vani and Professor Jaipriya Gopinath and her team for organizing this event. We also thank all our webinar participants. We are expecting the participations to rise, and we are expecting more questions to come. This was the beauty of the presentation, that there was a very exhaustive Q&A session towards the end, and faculties and students participated in full full enthusiasm. So that's what makes a webinar a success. So I'll now conclude with a special thanks to all faculty, students, and volunteers, and I thank you all. And again, I thank you, sir, for being a part of this event. I'm looking forward to more discussions with you in the future. Thank you.
Thank you, Karthik. Wonderful. It was really, really pleasant, rather. Very pleasant and explained in its most simplistic format. Yeah. And there were about 90 plus participants. It was good. On going by the stats of our college, 90 plus is a very good participation. Maybe in the days to come, it is bound to increase. Looking at the quality of the presentation. And my chairman wanted to thank you in person. So probably I'll see if I can call him now, or maybe post this. After we close this, we'll have a small conference call between you, myself, and Mr. Reddy also, with our chairman. If it is okay to you, unless you're going out somewhere.
No, sure, sir. Anytime. Yeah. My pleasure.
Yeah.
So I would also thank one and all, giving me this opportunity to present. Post probably once things normalize, we can have even physical sessions. I would love to come to Ooty and have larger sessions. If there are audiences, to really get into technicals of drawings, technicals of, the architectural element of it, because we have immense 20 years of experience and we can share so much of information. We are an abundant knowledge bank. So, once things normalize, I think we can have larger sessions, couple of hours, have a nice chit chat, and really we can present to you more of live pictures, live, drawings, which we carry forward. So a lot of things we can do. So this is just a basic insight, and lots more to come. We'll associate furthermore.
Oh, lovely. Sanil?
Thank you, sir, and thank you all participants.
Yes, sir. Thank you, sir.
Thanks a lot.
Thank you, sir.
Thanks.